What is AUC? AUC stands for Area Under the Receiver Operating Characteristic Curve. The ROC curve is a graphical plot that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. The AUC represents the area under this curve. It provides an aggregate measure of performance across all possible classification thresholds. What does AUC show? AUC measures the ability of a classifier to distinguish between positive and negative classes. It ranges from 0 to 1. AUC equals 1. Perfect classifier. The model perfectly distinguishes between positive and negative classes. AUC equals 0.5. Random classifier. The model performs no better than random guessing. AUC less than 0.5. Worse than random. This usually indicates a problem with the model or data. A higher AUC indicates better performance. Specifically, AUC can be interpreted as the probability that the classifier will rank a randomly chosen positive instance higher than a randomly chosen negative instance. When to use AUC? AUC is particularly useful in the following situations: imbalanced datasets, when one class has significantly more samples than the other, like in fraud detection, medical diagnosis, or rare event prediction. Accuracy can be misleading. A model can achieve high accuracy by simply predicting the majority class most of the time. AUC is less sensitive to class imbalance. Comparing different classifiers, AUC provides a single number that allows you to easily compare the performance of different classification models, even if they use different algorithms or thresholds. When you care about ranking or probability estimates, AUC evaluates how well the model ranks instances by their predicted probabilities. If your application requires ranking, e.g., recommending the most relevant items, AUC is a good metric. Which algorithms can use AUC? Any classification algorithm that outputs probability scores or a ranking of instances can be evaluated using AUC. This includes logistic regression, directly outputs probabilities. Support vector machines, SVMs, can output decision values that can be used to rank instances. Decision trees and random forests can output probabilities based on the proportion of training samples in leaf nodes. Gradient boosting machines, GBMs, like XGBoost, LightGBM, CatBoost, can output probabilities. Neural networks can output probabilities using a sigmoid for binary classification or softmax for multi-class classification, activation function in the output layer. How to use AUC? Most machine learning libraries provide functions to calculate AUC. Scikit-learn, Python, roc_awk_score function. TensorFlow, Keras, TF, Keras, metrics, AUC metric. PyTorch, requires manual calculation using the ROC curve. AUC versus other metrics. Accuracy. Accuracy is the proportion of correctly classified instances. It's simple to understand but can be misleading on imbalanced datasets. Use AUC instead of accuracy when dealing with imbalanced data. Precision and recall. Precision measures the proportion of true positives among the predicted positives. Recall measures the proportion of true positives among the actual positives. These metrics are useful when you care more about one type of error than the other, e.g., minimizing false positives in spam filtering or minimizing false negatives in disease detection. AUC provides a balance between precision and recall. F1 score. The F1 score is the harmonic mean of precision and recall. It's also useful for imbalanced datasets. However, AUC is often preferred for comparing different classifiers and evaluating ranking performance. In summary, AUC is a valuable metric for evaluating binary classifiers, especially on imbalanced datasets. It measures the model's ability to distinguish between classes and provides a single number that summarizes performance across all possible thresholds. It's widely applicable to various classification algorithms and is often preferred over accuracy when class imbalance is a concern or when ranking instances is important. When you need to focus on specific types of errors, false positives or false negatives, or when you need to choose a specific threshold, precision, recall, and F1 score become more relevant.